I will introduce the next speaker in English. He will inform us about international normalization and standardization in Europe, and also something about the holistic approach of the facade. He works in fire sciences since 25 years, and now he works for Effectis France as general manager of the company. Ladies and gentlemen, I would like to have your attention for Mr. Eric Guillaume.
Hello everybody, so thank you. So the presentation will be in English, but I saw that some of you speak French, so perhaps we could do also that in French if you prefer. So I'm very happy and very proud to be here with you today to discuss about these different problematics. And what I will try to do is share the experience we faced in different countries, just to give you also ideas and highlights on what's going on at international level, at the European level, and at different national levels in Europe. Because you will see we face exactly the same things. What I understood from the previous presentations is, I would say it's narrow because it was in Dutch, but no, it's exactly something that we face in every country. So let me just introduce Effectis before in a few words. So some of you probably know Effectis because Effectis is in the Netherlands since a while. But it's not only in the Netherlands, we are also present in several European countries with very, very large facilities in France, but we are also in UK, in Spain, in Italy, in Turkey. And in the Netherlands for sure. So it means that it allows us to have an idea of what happens in many different countries, contacts with regulator, contacts with the customers we have in the different countries. And sometimes they have questions because they don't understand why in one country we have something that is totally different from the other one. So, and sometimes we cannot explain why. So just the context, it's about external thermal insulation first. The problematic, you will see it will be highlighted in the upcoming months and weeks because energy is, I say building sector is a domain that represents a large part of the energy that is consumed in Europe. So I don't deal with the price of electricity and gas, which is the same problematic everywhere. But it means just that it will highlight this problem much more in the upcoming years. So what we have to do is to reduce the energy needs in buildings. We have national regulations, we have European directives on that, but we are facing at the same time the slow renewal of building stock, because when we build something, it's very often for 40, 60 years, perhaps more. And so we can have refurbishments and so on, but this slow renewal is very important. When we put in place a new thermal regulation, it takes decades and decades to be implemented at 100%. So all these elements are facing rapid change in the energy problematic, as we saw recently. And so the projects where we will have positive energy or refurbishment of existing buildings, things like that, will be more and more important. There's a need so to improve the thermal performances of new but also of existing buildings. And in existing buildings, one of the better solutions is a better insulation. In new buildings, it's sometimes more easy to implement, but in existing buildings, it's not evident. And we have several technical solutions. We can use internal insulation, but we have thermal bridges. We can use double walls, ventilated facade, ATX. We have plenty of other solutions. And not only, because we are also facing, I would say, I saw there was some architects in the room. I will say we are facing the architects. It's not a critique. It's just saying that the buildings are also more and more complex in terms of shape. It's not just a rectangular shape with a masonry and something that we don't build today as we built in the 60s and 70s. So we have curves, we have extensions, and all these are very important in terms of constraints to the facade. We will see later, but we have, for example, decorative panels on the facade that have nothing to say with any function except aesthetic. And they may matter in terms of fire safety sometimes. And sometimes the regulator forgot them because in his mind it didn't exist. We see also that we have more and more new products and new functions. So I saw these pictures before. It was laughing because it's a building in Paris. So but it's a typical example of what we see today is that we add functionalities to the building. So we had, for example, solar panels. Here it's a full facade full of PV panels, but it could be also integrated panels. And so this is a new challenge. We have, what is the definition of a facade when you have no masonry? The facade could be considered with the fire from the inside to the outside, but also from the outside to the inside. You have cavities in it, you have functionality like photovoltaic in it. So even the definition of the facade is challenging. So we have to focus on that. We have to think about what are the systems, and if we change the regulation, is it adapted to the future systems? So this is why performance-based and performance criteria are very important to be defined. If you have not a clear objective, you just put a reference to a level of performance, a class in fire, and so on. It's not enough because you perhaps miss a large part of the parameters. There's also another point that is important, which is the carbon footprint. It's political decision. You can be against having wood buildings everywhere and so on. It's a society, we will go. We have to be adapted to that. We will have biosourced insulant. We will have bio-based structure or mixed structure with concrete and with steel. So we have to consider that. You cannot say, for example, I want to have only non-combustible buildings over 8 meters because it will face the reality of the carbon balance of the country and so on, and it will not be accepted societally. So it's very important because we as fire safety engineers, we have to find a solution to accommodate that. We cannot say just, no, don't do that. So it's challenging. We have to find a solution. And the solution could be only based on the performance. We see so bio-based insulation. Sometimes it's new phenomena that we occur with that. We have a smoldering combustion in the insulants. We have release of some gases. I saw recently release of a large quantity of hydrogen cyanide when you burn sheep wool as insulant. It's awful, but it's used. We have vegetalized facades. So here, this is a picture of Quai Branly Museum in Paris. So it has been assessment from effectives, and here it's a totally vegetalized facade. This one, I will say it's good because it's tested, it's compliant, and it's well maintained, which is a very important parameter. It's a museum, a public museum. They have money to maintain it, and they make they still maintain water feed in summer and things like that. So it's a challenge. We will see some pictures, for example, of what could be the worst case for vegetalized facade. So at present time, we didn't deal with fire, so we go to fire. What are the fire safety issues with that? If we increase the thermal insulation, we increase the insulant thickness, for example. So we increase the quantity of potential fuel that is on the facade compared to the systems that we saw in before years 2000. We had a large increase in insulant thickness, for example. When I say large increase, it's sometimes 3-4 times more. So it's really important. The firefighting action, firefighting tactics are modified also by all of that. And it modifies also a fire scenario. Thermal insulation doesn't mean also only insulant, it's all the system. So we have to think about constructive system, all layers, from the inside to the outside. So what is a facade in terms of safety? It's really not evident, because is it an assembly of materials, of an insulant plus a cladding plus air gap and plus masonry or other things behind? Is it a construction product in the sense of European construction product regulation? Is this a constructive system, and what is a constructive system? And is it a part of the building? Honestly, we have no answer to that, because in each country we could have taken a different approach for that point. So, for example, I will take the case of UK, you will see later, but they decided that it's more a construction product, something that is like for CPR, something that is circulating. So they make an assessment at product level. In France, we consider more that it's a part of the building. So we have compliance building by building. So the approach could be different. And so for us, it's the last category. It's called by the regulation in terms of conformity of the building, not conformity of the components of the building. And there are also other threats. So we saw new materials, new constructive systems. And in terms of fire safety, it matters. It could be also a question of penetration. We saw the photovoltaic facade, penetration of the cables from the system to the inside. It may also add another threat, because if you have photovoltaic panels, it's for more and more auto consumption of the power. So it means that you have to have ESS, so large batteries in the building. And so you add a risk inside the building because you add a functionality to the facade. What is the life of a facade? This is another question. So the facade is never, so it's something that lives, so it's never as at the beginning. You see in the picture, it's a picture I took in Brussels, very close to the European Commission, where I had a meeting on fire safety of facades. And I think it was two buildings narrow, and it's a building that was unused, and it's a totally dried, vegetalized facade. And so here, if you look properly, you see there's also vegetalization in the angle here, so you have a D-head effect. It's the, I would say, the most awful condition for propagation. So we will see, we don't care, there's nobody inside the building, but you see, this is now a building that is just here. And if you have all stories that are burning in the middle of a city like Brussels, I think it will take problems to the neighborhood. So, and the neighborhood is the European Commission, so perhaps. It's a way to implement the change in the regulation, I think. So, the lack of maintenance add risks to the facade. The phases of construction also. We had several fires in construction phase, and it's more and more critical. If your system is based, its performance is intrinsically based on the protections you put on it. When you are in construction phase, you perhaps have not the protection in place. Recently, you had a very large wood building that burned in the middle of London. I don't know if you saw these pictures. It was really impressive, and firefighters cannot approach because of the radiation of such kind of fire. So they were close to lose a complete several buildings at the same time because of this phase of construction. And dismantling is also important, because nowadays we have to consider in the life cycle of our buildings the dismantling phase that will create also a risk, and what we do also with the materials in the end. Fire could be a way to incinerate them quickly, but there's another issue, which is a regulation issue. We regulate for products, we regulate for buildings, and in the middle there's a facade. It's not a product, it's not a building, it's a part of a product, it's a part of a building. So depending on the angle you take, you could be in the middle. If you take, for example, kits could be included as CPR products, and so this is CE marked, and this is really, I will say, followed as a product. But if you take, for example, curtain facade on high-rise buildings, it's really a national building code, nationally regulated. We will have different solutions and different requirements in each country. We could add fire resistance requirements and so on, for example. So this is very important because your assessment could be done at the two levels. And some countries, as I mentioned, choose one or the other. But the reality is probably in between. It's a gray zone. Another point that is important that need to be highlighted is the question of scenarios. When we make fire safety, we try to objective that facing reference scenarios since the beginning of the European harmonization. And first example is SBI. SBI has been defined as a correlation between this SBI test and what we call a room corner test. And room corner test, so the objective is to limit the occurrence of flashover from inside compartments of the building. This is the objective. The scenario is a reproduction in laboratory of what could be a small room with a small sofa that is burning in one side. And it makes the SBI in the end. But what is the extrapolation of facades? Do you think that the scenario of the fire in external fire is similar to the one in this compartment? Probably not. And at that time, for the implementation of CPD at that time to the different national regulations, I would say the participants to this work published a paper that was called Guidance Paper G. So Rudolf, probably you know that well because you probably participated to that. And in that point, there are sentences about facades. It's mentioned that the reference scenario is a fire development in a room, and it could be not considered as appropriate for products in certain intended use, and these certain intended use are typically facade fires, cited. So it means that at that time, at the beginning, they had a doubt about the representativity of SBI used for facades. We didn't develop the reference scenario for facades from that time, but we are in the 90s here. And this has been confirmed for CPR application. So nothing new. What are the reference scenarios for facades? We have to focus about the different fire scenarios that we face. We could have fire from external building radiating to another one. We could have fire behind the building, fire propagating the facade. So I just listed some of them, but we could have many of them. The last ones are important because they show you that it's not only a question of material that is present, but also of constructive system. And for example, in some constructive systems, the connection between the facade and the slab is of great importance for the fire propagation. In some other, it's less sensitive, but if you have to have performance requirement, you have to consider all these aspects. Here, this is just an illustration of a test we made on buildings that was dedicated to destruction, and so we can have played in it a lot. And we made just apartment fire and see what the flame pattern looks like for real fire in apartments. And here in France, we based our strategy in the past largely on horizontal and vertical deflection of flame. And we see that it's not necessarily relevant or not enough because even if you have a non-combustible facade, it doesn't mean that your fire will not make jumps, leapfrog, we say, from one story to another. The question is not that it's not possible to have this leapfrog effect, it's just that it has to be compatible with the action of firefighters. Meaning, if you take from one story to another every 30 minutes, it's supposed to be compatible with the action of firefighters. It's written nowhere except recently in a UK document, PAS 9980, that writes that explicitly. So, what happened from 2017? So 2017, we had a Grenfell fire. We will go back in it. But prior to this fire, so it's interesting to see that one fire started to make a change in many countries in Europe, and the time it took. I take another example. So there was a Great Fire of London in 1666. Okay. At that time, so I'm French, so sorry. Louis XIV, King of France, decided, he understood that it was a problem if something similar happened in Paris. I think it was more about the problem with the population that was very unhappy with that, more than the fire safety itself. But he decided to make mandatory to have plaster on all visible wood from the outside and the inside. And it was 1 year after that his decree appeared. So nowadays, Grenfell burned in 2017, and we are implementing changes in different European countries. So we take more time, but we are not King of France, so that's probably why. So energy efficiency policies request to improve this thermal performance of buildings. I mentioned already this low renewal of the building state and of the building stock, sorry, and all European countries had provisions for their facade requirements in terms of fire safety, all of them. But we will see it was really different from one country to another. The regulations were mainly based on the existing European system on reaction to fire, so Euro classes. And 14 member states have additional requirements that were based on large-scale test methods. So these large test methods, we had a lot of them. And they are listed just here. I saw that you had also a similar table in your presentation, Rudolf. So we had many different test methods, and if we look at them, they are all more or less simulating part of building, but they are not so similar. If I take, for example, BS 8414, in UK, they estimate that the worst condition was to have the maximum quantity of fuel on the facade. So they make a fire chamber that is supposed to reproduce a fire inside an apartment. They have a lintel, and then they look at the propagation on a corner with the insulation product. There are two parts, one on masonry and one on other systems, so we'll say. In France, or in Sweden also, Sweden is here, we estimated, the basic hypothesis is not the same, because we estimated that it was important to have a window on the facade. And why we estimated it was important to have a window? It's because we had a lot of systems that we tested that failed because of the details. Especially, for example, polystyrene ATX, when the window frame is not close enough, or if you have no the proper barriers, then the fire will enter by the window and the window details, and you will fail the test because of that. So the basic understanding of the objective of the test was not the same. So in UK test, it was only vertical propagation. In French test, it was a question also of propagation and penetration to the upper compartment. So criteria are also very different. The objective, in fact, is just to assess that the facade is safe or not, but the understanding of the objectives is not the same. And it's perhaps because at the time the test was defined, there was a limited number of constructive systems, and it was the right choice for them. But with the time, it was not evident that it was still valid, this hypothesis. We had also a report, so we are prior to Grenfell, and that was done by Fire Safe Europe and presented to FIEP in end of 2017, so after Grenfell. And we have the same elements with the list of the different requirements that we had from different kind of buildings between the different European countries. We see at that time Netherlands and Belgium, no requirement. This is in the report, it's not me. Then Grenfell tragedy occurred. So we heard a lot about Grenfell tragedy, but in fact the judgment is not done. So what we could say is that as even when we have such catastrophic event, is that is a combination of several failures. There was a failure in the choice of materials, but it was compliant with what they asked at the time. There was a failure in fire resistance of the building because fire penetrated to all apartments. There was also a failure in the choice, the strategy of letting people staying put in the building instead of evacuating. It's a judge that will have to manage that, but I would say it's not just a question of having a flammable surface on the tower, because the same kind of material you see every 6 months on Dubai, a tower that is burning and fire don't penetrate. Why? Because they have also requirements in fire resistance from the outside to the inside. So the integrity of the building is still kept. So there's no penetration of the fire. It's spectacular, you see large flames, but here you see the same flames and you have the penetration. So it makes a catastrophic scenario. So prior to Grenfell, European Union started to propose a route for harmonization of facade testing. It was before, and this has been for sure accelerated. We made a first report that is available on the development of a European approach to assess fire performance of facades. So for building products, we took 30 years for the interior. So imagine here we started in 2017. So it will take time. So I know some of you are counting if they will be still active or not at that time in 30 years for that. No, the problem is that the implementation is also very complex. So at this report, it has been identified because, as we mentioned, facades are not fully a construction product. It's also a constructive system, a part of the building. It's covered by national regulation, and its components could be covered by European ones. So this is in between, and it's not evident. Roofs are also in the same situation, but roofs are less sensitive to major fire events. And post-Grenfell, several countries decided to change their regulation. Most of the requirements that were not so set are set in Euroclass very quickly after, with provision of large-scale tests in some countries. And most of the countries did or are going to change their regulation post-Grenfell. I will detail you country by country. And what makes the move is political reason, is media impact. It's not just a question of safety. It's really a question of image. And I will say perhaps what you are doing in the Netherlands seems to be different, but in many of these countries, they decided to move without necessarily a technical basis that supports the choices they made in terms of regulation. For example, in UK, just after Grenfell, so it was dramatic, they say, okay, we ban all combustible elements in the facade, but for windows you have joints, so how do you do? Non-combustible joints on the window, I didn't know that. So it's not so simple. And what is a non-combustible? It's also related to a scenario, so it's really not evident. The assessment is challenging, so we understood this regulation question, but when you perform tests, we perform tests on a model of facade. We perform not tests on facade itself. So Depending on the countries, your model is more close or far from the reality of a given project. So you need to have very often additional assessment of the deviation between the test model and the reality of what is built. We cannot test all configuration. It's not a question of, it's a question of test capacity, but it's a question of time, of market, of money. We cannot test all the configurations that are possible in terms of facade. So we have to make some choices. We make the choices and we make assessment in the end to validate case by case what happened in a given project. So I will say very often the test results are generic and the visa or the assessment is tailor-made project by project. It's not so evident because sometimes we perform, for example, tests specifically to a given project. So we try to be so close as possible to the end-use conditions. And sometimes, for example, we took the choice in France to have a large base of test results to be able to make a guidance. And this guidance allows us to validate at one time a large range of different configurations. For example, in polystyrene ethics under mortar, we made some rules, some tests. We took perhaps 30, 40 Lepier tests, and then we validated a full range of possibilities. And if you are in the guidance, it's accepted. So it's a way to progress for a given family of system. What we could do to do that, test results are only one of the bricks. There are also historical data that we have. There are also intermediate scales tests. There are also feedback from the different fires. And I think some colors passed, but large-scale test method is one of the points of the compliance, as well as on-site expertise and assessment protocol and responsibility. So we have the most important is that when you have an engineer, a consultant, an advisor that make any assessment on facade, he has to understand the risk, he has to understand the facade, he has to understand the scenario, he has to take into account these different levels of information to propose the application in the case or the extended application for a given range of products. So in the rest of the presentation, I give details for selected countries, so I will go quickly. In UK, in fact, there's no UK regulations. There's one in England, there's one in Wales, one in Scotland, and one in Northern Ireland. So it's very simple. There are 4 regulations. And for the 4 regulations, they have provisions that are quite common. So just after Grenfell disaster, they made audits on existing buildings. They decided to stop what they called desktop study, which was really desktop, meaning assessment without any experimental data or with weak experimental data. And they ban such kind of practice. They ban the combustible material of a wall facade, but they saw that it was not practically implementable, and so they changed a little bit the way how to do that. And they banned the former national classification for facade elements and refer to European standards. So it's at the same time as Brexit. So it's, and they also revised by the time their different regulations, and in fact, simply they say that if you are more than 18 meters, you have to have a large majority of materials, which is A2, S1, D0. And in lower buildings, facades that are classified as B or C could still be allowed. And they have to perform a BS 8414 tests. And they also progressed on issuing a document for extended application, which is BS 9414, which in fact say to you that you have to test everything. It's oversimplified, but I invite you to read that. And they are working on improvement of their different documents. And they also started research programs because they said, okay, we have to have supporting research programs for the future. And there one for external walls and balconies, which is undergoing and which will be finished in 2 years from now. In Scotland, I don't detail, but it's very similar. In France, so what happened in France? We, in fact, started before Grenfell tragedy because since 28, our regulator said, okay, I had prescriptive solutions that were accepted, deemed to be satisfying the objectives. And they were explicitly cited in the regulation, like different thicknesses of polystyrene on different mortars and so on. And with the multiplication of the different systems on the market and some accidentology we had in the beginning of the years 2000, the regulator said, okay, I stop the game and you have to retest everything. And they started to retest Lepier for a lot of systems. And we performed hundreds full-scale facade tests to have a new technical basis for that, new technical knowledge. I saw, I think it was in your presentation, that we had a Roubaix fire. So Roubaix, this is a picture we have here. This is an ACM PE panels, but they are not on the facade. They are decorative panels, and they were not considered in the regulation at that time. And they are still not considered in the regulation. So this building is compliant with the regulation. And in this building, we had only one fatality. I think it was in the apartment here, and it was an old lady with which was unable to escape because of medical reasons, and so so it's unacceptable. It's unacceptable, and in the next revision of the regulation, it will be forbidden for that kind of application. When we made, just after Grenfell emergency measures, we counted that there were 12,000 buildings in France that were potentially of interest for that, which is a lot. And we proposed with CSTB a plan of audit for these buildings, because they are perhaps not all at risk. And in fact, I think the ministry forgot to do that. We had modification of the regulation in 2019 for dwelling, which is because we have a strange category that exists only in France. In the 70s, we had to build quickly a lot of buildings, 60s and 70s, especially because we had the end of Algeria, of French Algeria, and so on. So we had a lot of people that came back to France, and we had to crisis of dwelling, in fact. And so they had to build very quickly a large number of apartments. And so they created a category in the regulation for buildings that were dedicated to dwelling, more than 28 meters, less than 50. But it was not high-rise buildings. So I would say it was high-rise buildings with lower requirements. And these are the problematic category we have today. So nobody wants to live in these buildings today, but it's a category that gives problems. In above 50 meters and above 28 meters for the other, we have an assessment, and we have quite non-combustible buildings, so the high-rise buildings in France normally are safe, except this category, this strange category. And the regulator decided to wait for the European harmonization to integrate the new large-scale test method that will be developed in the regulation, but the text is already ready to replace leap year by another test in the future. So I will not detail all the countries. You will have the slides, I think, so you will have all the details for everybody. Here, this is Belgium, Finland. So I put a lot of different countries, and you will see the criteria are different in terms of height from one country to another. Very often you will see the 28 meters because it's the size of the ladder of firefighters, largest one. But the limit at 56 meters, 50 meters change from one country to another. I don't know if you already tried to be at the top of a ladder of 28 meters, but it's interesting. So you have that country by country. I put Netherlands, but I will let you check if I didn't put a mistake. I asked to my colleagues, but few weeks ago, so perhaps it's not up to date. And the same for Spain, and I put Italy. What is interesting is that Italy changed the regulation this summer, and it changed for large-scale tests. And you know, in Italy, the ladder are probably smaller because it's 12 meters and 24 meters. And we see that they have -1 meter. I suppose it's because they anticipated also the need of Netherlands, which are under the sea. So I don't know. So what is the ongoing roadmap with all of that? In ISO, we have a group that is ISO TC92, which deals with fire safety, and there's it's missing a subcommittee 1, working group 7, which deals on facades. This group already covers several test methods, including the ISO 13785 Part 1 and 2. These standards are existing at present time. That could be improved. Part 2 is rubbish because you have several solutions to make the same thing, so I will not detail. But Part 1, it's interesting, and we identified that there was a need to have a roadmap, to have something coherent in facades, and also we decided, and in fact NEN decided, to propose a revision of ISO 13785 Part 1, and there's a preliminary work item on that has been decided. It was in Delft last month, so it's fresh news. And we will develop, improve this document, and it could be very interesting for the application you will have in the Netherlands for the future. CEN-TC 127 is waiting for the mandate corresponding to EU research program. I will detail you that just after. And for CE marking, you have some product standards that appear, especially for kits, so predefined facade systems, where we start to have such kind of systems that could be CE marked. What about buildings? Because here these are product assessment and so on, but harmonization of regulation in or building regulation in Europe, it will be a long road. I don't know if member states will want to do that. It's not evident. We just finished a research program on statistics, and it was challenging to see how the different European countries collect their statistics and use them, and it's not evident how they will be able to collect the statistics in the same way and use them in the same way. And it seems simple compared to regulating on buildings, but at the same time, we don't know what will be the future, and perhaps we could harmonize in the future, for example, building by building. I don't think an hotel in Netherlands and in France is so different, so we could imagine a directive on hotels that give requirements on fire safety. How it's opposable to local regulation is not evident. The European Research Programme, there's a phase 2. So I mentioned the report previously. The phase 2 is ongoing. We performed a theoretical round robin. We studied a lot the fire sources. We have issued several reports at present time. And what it looks like is that there are two sides of test method. And especially the most important one is the large size. The large size is similar to BS8414 size, more or less, but with a secondary opening, a window, a dummy window in it, to reproduce the weak points that could be provided by a window frame. And we defined different levels of exposure and a system of classification for that. And we will do an international round robin that will start in the beginning of 2023 to see, for example, if we could do that exclusively indoor, or if we could do that indoor and outdoor, and what are the limits of the method, what are the criteria of repeatability and reproducibility, notably. So this is the work that is ongoing. From this work, there's a route to SEN. So this is the view of, I would say if I come back in 6 months to present you the update, it could be different, but it gives you an idea of the time frame now. And it means that we could have a European standard that is available in about 10, 15 years. So it means that if you have nothing, do something, because you will have time to use it. And after, you could come back around the table in 15 years and say, okay, now I implement the European test, for example. But the time frame, it's about that. So it's long. So in conclusions, some countries reinforce their requirements after Grenfell tragedy, especially for the highest buildings. The use of large-scale tests is done on different ways depending on the countries. It doesn't cover all aspects. Intermediate scale tests are very important to fill the gap and to make project by project assessment or extension of application from a large scale test. One point that is very important is the education for all parties, on-site assessors, architects, material suppliers, and so on. They have all to improve their knowledge on that. And so I think the education is one of the important points. And the trend in Europe is it converges, in fact, but with different building definition, different local national regulations, so it will take time. I put in the presentation the links to all the data from the ongoing research program and also the existing reports that are available. And I'm available for any question about all of what I said here. Thank you.
Eric, thank you very much for your very interesting presentation. Are there any questions from the public?
Ik ben Geert Ruiter. Question, the incident in Roubaix with only one fatality. Was it because the fire brigade was able to intervene on time, or were people in time out of the building?
In fact, they faced the compartmentation inside the building was good, so the fire entered in the different apartments from the balconies, especially when there was a fire load on the balconies, because you had people that put many things on their balcony, and so, but it didn't went outside the apartments, and we had no propagation of smoke, for example, inside the circulations inside the building. And so it's really, there was no fatality. It was in the middle of the day, and people that were present all escaped in time. But really, the except one person that was at reduced mobility, and she was on her bed, and she died because she was exposed to smoke at that time. Yeah, there was not necessarily a lot of propagation of the fire inside the apartment, but mainly smoke. Yeah. And it was ACMPA. And as I mentioned, decorative panels. So it was nothing related to the facade in terms of regulation.
Yeah. In the meantime, until all the new regulations are effective, about 15 years, is it wise to try to influence human behavior during a fire? That people are more aware what they should do in case of a fire. Stay inside or just not stay inside and get out of the building.
This is an excellent question, because if I take the case of Grenfell, so it will be judged, but one of the problematic was that the strategy that was in the manual of firefighters in UK was stay put. So because the manual was based on previous experience where they said, okay, it's too risky to evacuate everybody at the same time in the staircase, so we suppose that the fire will go slowly from one compartment to another, giving us time to fight. And so we could manage the fire just evacuating the compartment where the fire is and the compartment above and below. This was really their strategy. But during the fire, they didn't move from their manual, and they didn't understood that the fire was entering into 24 compartments at the same time. And so with this massive entrance of fire, there was no victim on all the apartments that catch the fire first, because all people saw the fire and escape. But the others were trapped because they didn't saw the fire and they didn't have the order of evacuation. So it means that strategies of evacuation in building are probably not unique, and if you have a regulation that is too rigid, you fail. And the problem, if I detail in Grenfell, is that they faced a few years before another fire, facade fire, that was La Canal Street fire, where they had, I think, 7 fatalities, and it was due to the external propagation and this stay-put strategy. And they were condemned by the court to change their strategy, and they didn't do anything. So their responsibility is in cause for that, not for the action of firefighters on the time of the fire, but for the education, the training, and the manual that was not adapted to the reality. So it means that if you have strategies like stay put, they cannot be unique, and evacuate quickly everybody cannot be unique also, because it's not evident. But if we will have wood buildings, for example, we will probably have to have a delayed evacuation. So we have to manage the evacuation, to consider this management of evacuation in the design.
Thank you for the questions, and thank you for the replies.